Algebra 2, Chapter 9, Section 4, Rational Expressions. What we're going to cover in this lesson is we're going to learn how to simplify rational expressions and multiply and divide them. Okay? So what is a rational expression? A rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors. So let's look at the examples in the notes here. In simplest form, x over x minus 1, 2 over x squared plus 3. Not in simplest form, x over x squared, we can factor out an x. 1 over x over 1, or x plus 1, that's not simplest form. 2 times x minus 3 over 3 times x minus 3. You can simplify some expressions by dividing out common factors. Don't forget this. Restrictions on the variables may be needed to prevent division by 0. Okay, so let's just get into it. It says simplify x squared, and I'm going to rewrite it down at the bottom, x squared plus 10x plus 25 divided by x squared plus 9x plus 20. Okay, first thing we need to do, okay, let's factor the numerator. Okay, so the numerator was x squared plus 10x plus 25. We could x factor this. Okay. A times c is 25. My b is 10. Two numbers that give me a product of 25 and a sum of 10. Well, that's 5 and 5. So I know the numerator is going to be x plus 5 times x plus 5. So I'm going to write it over here. X plus 5 times x plus 5. Now, let's use orange and let's do the denominator. The denominator is x squared plus 9x plus 20. Same thing, we can x factor it. Our a times c value is 20, our b value is 9. Two numbers that give me a product of 20 and a sum of 9. 5 and 4 seem to fit the bill, so we can rewrite this as x plus 5 times x plus 4. Well, that's the denominator now. So now we can rewrite it over here, x plus 5 and x plus 4. Okay, before we cancel anything out, let's find our restrictions. What are our restrictions? Things that make the denominator 0. So x cannot equal -5 and x cannot equal -4. Being -5 or -4 gives me a denominator of 0, which we cannot have. So there are my restrictions. Okay. Now let's look. What can we cancel? All right. What can we cancel right here? We can cancel the x plus 5s. So our final answer in most simplest form is going to be x plus 5 over x plus 4. X cannot equal -4 or -5. So that's my final answer. All right, next example. Simplify -27 x cubed y over 9 x to the 4th y. State any restrictions. Well, right now, based on what we see, we know x cannot equal 0 and y cannot equal 0, because if either of those were zeros, the denominator would be 0, and that's not right. So let's look at it again. -27 x cubed y over 9x to the 4th y. So let's see if we can simplify. There's a y on top, y on bottom, they cancel. All right, there's x cubed up top, x to the 4th on bottom, so we can rewrite this. 4 minus 3 is 1, so there's 1x on the bottom. 9 on the bottom, -27 on top. We can cancel that out and put -3 on the top. So we have simplified it to -3 over x with restrictions of x cannot equal to 0 and y cannot equal to 0. Okay, and that looks like answer B. All right, 1b. Simplify -6 minus 3x over x squared minus 6x plus 8. So let's start with the numerator. Okay, the numerator is negative 6 minus 3x. So what can we factor out? What's the GCF of the numerator? Well, I can factor out a negative 3. And when I factor out a negative 3, I get 2 plus x. So there's my numerator. Okay, I don't have to worry about restrictions because it's the numerator. Let's look at the denominator. The denominator is x squared minus 6x plus 8. Okay, let's x factor. What's my a times c? It's 8. What's my b value? Negative 6. So two numbers that have a product of 8 and a sum of 6. So they both need to be negative. Well, negative 4 and negative 2. So I can rewrite this as x minus 4 times x minus 2. So that's my denominator. Now, remember, the denominator cannot equal 0, so we got to have some restrictions since there's variables in the denominators. What would make this first term 0? X minus 4. So that would be x equals 4. Well, can we allow it to equal 0? No, so x cannot equal 4. So what would x have to be to make the other grouping 0? 2. So x would equal 0, but it cannot. So we found our restrictions. X cannot equal 2 or 4. And so let's rewrite this. So I have negative 3, 2 plus x, that's just my numerator, divided by x minus 2, or x minus 4 times x minus 2. Can I simplify it anymore? No. What are my restrictions? X cannot equal 2 or 4. So my answer looks like A. Alright, 1C, simplify 2x squared minus 3x minus 2 over x squared minus 5x plus 6. So let's look at the numerator. So I have 2x squared minus 3x minus 2. So let's do our x factoring. What's my a times c? Negative 2 times 2 is negative 4. My b is negative 3. So two numbers, a positive and a negative, with a bigger negative number, have a product of negative 4 and a sum of negative 3. Well, negative 4 times 1 meets the criteria. Okay, but since my a value is not 1, I have to replace that negative 3x with these two terms. So let's rewrite that. 2x squared minus 4x plus 1x minus 2. Now, from earlier we learned we could group these. We factor out a 2x on the left side, make that x minus 2. And we factor out a 1 on the right side and get x minus 2. So now we can group these together as 2x plus 1 times x minus 2. So that's our numerator. Okay, I'm going to draw that over here. 2x plus 1 x minus 2. Alright, let's work on the denominator now. X squared minus 5x plus 6. Let's x factor this. My a times c value is 6. My b value is negative 5. So two negative numbers that have a product of 6 and a sum of negative 5 would be negative 3, negative 2. So I can rewrite this as x minus 3, x minus 2. Since it's the denominator, we're going to have some restrictions. So x would equal 3, so it cannot equal 3, and x cannot equal 2, because our two groupings cannot equal 0. Alright, so let's write the denominator over here. So all that is over x minus 3 times x minus 2. What cancels? Well, the x minus 2's cancel. So my final answer is going to be 2x plus 1 over x minus 3. And x cannot equal 2 or 3. Okay, let's move on to the next one. Okay, now multiplying rational expressions. Okay, multiplying rational expressions. So it says multiply 2x squared plus 7x plus 3 over x minus 4, and x squared minus 16 all over x squared plus 8x plus 15. So let's write this out. 2x squared plus 7x plus 3 all over x minus 4 multiplying by x squared minus 16 over x squared plus 8x plus 15. Okay? So let's do something real quick. Let's do the first numerator. So I'm going to call this numerator 1, this denominator 1, this area numerator 2, and denominator 2. So numerator 1 is 2x squared plus 7x plus 3. So if we x factor this, we get 6 and 7. So two numbers are going to be a product of 6 and a sum of 7. So 6 and 1. So I can rewrite numerator 1 as 2x squared plus 6x plus x plus 3. Now we can group. So we can pull out a 2x and make that x plus 3. Pull out a 1 and make it x plus 3. And rewrite the first numerator as 2x plus 1 times x plus 3. So that's numerator 1. So we're going to rewrite it here. 2x plus 1 times x plus 3. Okay, let's look at denominator 1. It's x minus 4. Nothing to really do there. X minus 4. Alright, let's look at numerator 2. X squared minus 16. Does that look like a difference of squares? Sure does. So that's x minus 4, x plus 4. So let's write that over here. X minus 4 times x plus 4. Alright, let's do denominator 2. We use green. So denominator 2. We have x squared plus 8x plus 15. So my a times c value is 15. My b value is 8. So two numbers that give me a product of 15 and a sum of 8. 5 and 3. So I can rewrite this as x plus 5 times x plus 3. X plus 5 and x plus 3. Alright, now that I've simplified the whole expression, let's go ahead and find my restrictions for all the denominators. So x cannot equal, that would be 4, negative 5, and negative 3. See if you can figure out how I got 4. It's for the first term. How did I get negative 5? That term. How did I get negative 3? That term. So I found my restrictions. Now can we simplify? Yeah, I can cancel out an x plus 3. And I cancel out an x minus 4. So I can rewrite this guy as 2x plus 1 times x plus 4 all over x plus 5 with the restrictions listed above. Okay? Next example. Multiply a squared minus 4, a squared minus 1, and a plus 1, and a squared plus 2a. So let's look at a squared minus 1. So let's look at numerator 1. A squared minus 4 is a difference of squares, so I could write that as a plus 2, a minus 2. Okay, so let's do that in this little spot right here. A plus 2 times a minus 2. Alright. Denominator 1 is a difference of squares as well. A squared minus 1, which is the same as a plus 1, a minus 1. So let's write that. Actually, we're going to write it down a little bit. Let's do it down here. A plus 1, a plus 2, sorry, a minus 2 over a plus 1 times a minus 1. Okay. Let's look at numerator 2. There's nothing to do there, so we're just going to go ahead and put a plus 1 in its spot. Go ahead and put groupings around it. So let's look at denominator number 2. Denominator 2. So that is a squared plus 2a. Well, we can factor out an a and make it a plus 2. So it's going to be a times a plus 2. So let's look at the denominator. Let's look at restrictions. Well, a cannot equal negative 1. A cannot equal 1. A cannot equal 0. And a cannot equal negative 2. So we have a lot of restrictions. I'm going to relist them all. A cannot equal negative 2, negative 1, 0, or 1. Can I simplify? Yeah, I can factor in a plus 2. And I can factor out a plus 1. So my answer is going to be simplified as a minus 2 over a times a minus 1. With the restrictions listed above, that is my answer. Alright, so I would go with B. Or not B, sorry, D. Alright, next example. Divide rational expressions, okay? So here's what we got. We got divide 4 minus x over 3x plus 2 times x minus 2 divided by 5 times x minus 4 over x minus 2 times 7y minus 5. So let's look at this real quick. So we know right now the denominators of both terms cannot be 0. Well, since the left term, I'm going to circle in blue, is divided by this entire right term, the entire right term cannot equal 0. So not only can the denominator not equal 0, in this case the numerator cannot equal 0 either. So we have all those restrictions. So let's look at our restrictions. Well, x cannot equal negative 2/3. X cannot equal 2. X cannot equal 2. Y cannot equal 5 over 7. And x cannot equal 4. So that's a lot of restrictions. So let's rewrite that. So x cannot equal negative 2/3, 2, or 4. And y cannot equal 5/7. So there's part of it. Now let's go back and see if we can do anything to it. Well, if we're going to divide, let's go ahead and rewrite it real quick. So I have 4 minus x over 3x plus 2 times x minus 2. Well, if I'm going to divide a term, I can really just multiply by its reciprocal. So I'm going to erase it aside and we'll multiply by its reciprocal. The reciprocal is x minus 2 times 7y minus 5 all over 5 times x minus 4. Now let's just see what we can slash and burn. Well, what do you notice about the 4 minus x and the x minus 4? Well, they're really the same thing if I can factor out something. What can I factor out of either of them to make it right? Well, let's look at 4 minus x. If I factored out a negative 1, I could rewrite this as negative 4 plus x. Okay, and I scratch that out. And what is negative 4 plus x? Well, it's the same thing as x minus 4. So let's see what we can factor out now. I can factor out the x minus 4 and the x minus 4, the x minus 2 and the x minus 2. So now, with my restrictions listed above, I have on top negative 7y minus 5 all over 5 times 3x plus 2. Okay, that is my final answer with the restrictions listed. Last example, divide a squared plus 2a minus 15 over a squared minus 16 by a plus 1 over 3a minus 12. So let's rewrite the equation. A squared plus 2a minus 15 all over a squared minus 16 divided by a plus 1 over 3a minus 12. All right, let's look at this. Okay, well, we already know any denominator cannot be equal to 0. But since we're dividing by the second term, the numerator of that cannot be equal to 0 either. So let's simplify. Let's look at numerator 1. Let's set this thing up. Numerator 1 is a squared plus 2a minus 15. So let's x factor that guy. My a times c value is negative 15. My b value is 2. So two numbers, positive and negative, that have a product of negative 15 and a sum of positive 2. Well, that could be 5 and negative 3. So we can say that is a plus 5 times a minus 3. So that's numerator 1. So we're going to write it over here. A plus 5 times a minus 3. All right, draw a little line. Let's do denominator 1. That's a squared minus 16. Well, that's a difference of squares, so that's just a minus 4, a plus 4. So we can write that over here. A minus 4, a plus 4. Okay, but now let's look. Now, I'm going to go ahead and solve for numerator 1, but instead of dividing by this, we're going to multiply it by the reciprocal. So I'm going to flip, let's see if this makes sense to you. I'm going to flip this on the bottom and that on the top, because multiplying by the reciprocal is the same thing as dividing by a number. So, well, the numerator 2 is already in easy form, a plus 1. So we're just going to plug that in right here, a plus 1. Okay, and the last term we got to work about is denominator 2, and it is 3a minus 12. So I can factor out a 3 and make that a minus 4. So we're going to put that up here as 3a minus 4. So again, what terms cannot have zeros? Those right there. So what would make those zeros? Well, if a equaled 4, if a equaled negative 4, if a equaled negative 1, or if a equaled 4. So I have my restrictions. A cannot equal negative 4, negative 1, or 4. So can I simplify this now? Let's look. I have an a minus 4 on the bottom and a minus 4 on the bottom. And that is it. So I can rewrite this as 3 times a plus 5 times a minus 3 all over a plus 4, a plus 1. So with the restrictions we have listed above, that is it. Please review. This is your lesson for Chapter 9, Section 4.